So I'm not super actually, right? Yeah. More about like kind of character development. What was your favorite character?
Okay. Hope you can see my slides. Do you hear a lot of background noise? Or you can follow?
I can see.
Is the audio clear? You have a lot of background noise. You hear a lot of.
Yes, so far so good.
Okay. So yeah, let's get started. So today we are going to focus on load balancers and health checks. Last time we hosted an application, a PHP application on one of the EC2 instances. So we are going to follow some kind of good practice today where we just do a load balance, implement a load balancer. So you guys, you have any questions from last session? What we can.
Yep, we can continue.
Okay. So when you consider load balancers, like as the name suggests, they are just balancing the load. So if you have multiple web servers, their task is to distribute the traffic to your web servers, and this set of web servers that you direct your traffic to, you call them a target group. And load balancers have something like a listener rule. So if a user specifies a particular uh, subdomain in the web application or particular path like an API, those can be directed to different target group, different web servers. That is how load balancers work. And then load balancer is one of the components that you place in the public subnet, so that provides protection to your web servers that are in the private subnet. We have this service called Web Application Firewall in AWS that can be associated with a load balancer. So it protects from unintended usage of the application. Like if somebody tries to run certain SQL queries in your load balancer of the application, those kind of requests are denied. So that way it protects your application too. So AWS currently has like 4 types of load balancers. We usually use the application load balancer. So application load balancer is operating in the layer 7 of the OSI network model, if you are familiar with. So there are 7 layers in a network infrastructure that we talk about in that model, and application load balance is operating in the layer 7. It's the it's handling mainly the HTTP and HTTPS protocols, and it supports like different types of listener rules. Like you can route your traffic based on path, based on domain, and also security groups can be associated with load balancers too. Now the next one is the network load balancer. So that is specifically for heavy network traffic. If you want to process like several million requests per second, uh, for those kind of very high network demand, you use these network load balancers. They are operating in the layer 4 at the TCP layer of the OSI model. And then we have this classic load balancer. So they are not used in a regular usage, but some of the legacy systems. So there's a type of it should be for classic EC2s. So some EC2s that started before the VPCs were introduced in the AWS, we refer to as classic EC2s. So for those type of web servers, to direct traffic to them, you have to use a classic load balancer. And gateway load balancer is something new that was introduced few years ago. So it's again for a specific aspect of the load balancing, but I personally don't have much experience with that. And so I just mentioned here for the completeness only. So load balancers, they have something called cross-zone load balancing. So what that means is, now you remember we created VPC and then we created two public subnets. Okay, so now you can actually have two load balancers in both those two public subnets as it is shown here. Okay, and then if you enable cross-zone load balancing, one the load balancer in zone A can direct its traffic not only to the web servers in its availability zone, but also to instances in another availability zone too. So similarly, this load balancer can also direct traffic not only in this availability zone, but also to the other one. So when cross zone, so that means load balancer can route traffic across availability zones. So if you don't have that feature enabled, this is how the traffic will be distributed. So you direct 50% of traffic to this load balancer, 50% of the traffic to this load balancer. Then, based on the number of instances in that availability zone, traffic will be distributed. So 25% goes here, 25% goes here. Out of the 50% that comes here, this is how the load will be distributed. So it is a good idea to, for availability purposes, it is good idea to have cross-zone load balancing, because in case one of the availability zone goes down, the application can still handle traffic. Uh, like so, if this availability zone goes down, what would happen is this load balancer will divide the traffic to each of these, like 12.5% of traffic will go to each of these instances. So that is the importance of having the cross-zone load balancing. And for your information, application load balancers usually cross-zone load balancing is enabled, but network load balancers you have to go and enable it manually, unlike the application load balancer. So this is one of the best practices of infrastructure implementation. So you usually now in the last workshop, what we did was we hosted our web server in the public subnet. So we reached that web server from the internet directly on port 80, and we placed only the database in the private subnet. That is not a good practice. This is the best practice because our servers should be in the private subnet. So what happens here is when a user requests particular web page, it comes to the load balancer, and the load balancer directs the traffic to the web servers in the internal network, internal private subnet, and then uh, the web server and database, as they are in the private subnet, they can communicate with each other. and then give the response back to the user. So this is the best practice that we are going to implement today. And then we are going to study how the auto scaling happens. So, so there are two aspects of scaling we need to understand. One is the one we call as vertical scaling or scale up and scale down, and then horizontal scaling, which is also called scale in and out. So vertical scaling, what happens is, imagine a situation you run a T2 micro with a certain CPU and memory, and sometimes your application reaches a bottleneck. Your users upload so many large files, or your program becomes so complicated, it needs several threads running and all. So your CPU utilization or memory utilization goes super high. And then you will need to you will reach a bottleneck and you will need to scale up. So one option you can do, you can host your application in a bigger instance. Like instead of T2 micro, you can go to T2 extra large or T3, or there are several uh, bigger sizes available. So you can move to one of those larger sizes. So one disadvantage of this is that there will be a downtime because you have to deploy your application from the smaller instance to the larger, and you have to detect traffic to the new instance uh, because you cannot increase the CPU memory when the application is running. You have to have a shutdown. So there is one disadvantage of vertical scaling. But if you go to horizontal scaling, you don't have that disadvantage. You see here. So imagine you have a T2 micro instance. When it reaches a bottleneck, you deploy another T2 micro. If that is bottleneck, we go to another T2 micro. Like so you can have uh, any number of micro instances to handle the load. And another disadvantage of this vertical scaling is there is a maximum limit you can go, right? Based on what AWS currently offers, there is a maximum number of CPUs and memory that you can give for a particular instance. And you cannot go beyond that. And sometimes when your peak load is gone, you may be your resources may be idle. You will have to scale down because otherwise you will be paying for higher CPU and higher memory, even though you used only like 1% or 2% of that. So this is how the scaling happens, and then so this happens is like you provide give a certain metric. You say okay, if the CPU utilization goes above 80%, goes above 75%, add another instance. So then it will spin up a new micro instance, and then uh, you, that new instance will be added to the target group. So load balancer has another new instance to route your traffic to. So that is how the scaling happens in the actual environment. If you have any questions, please free to ask. And then, so we will get into the console and see how to implement this best practice. I'm going to sign into my console. And I'll share that uh, AWS credits that I received, the coupon codes. You should be able to put that to your account because today we are going to use load balancers, and that will take you out of your PTO.
Hi, Harsha. I have a quick question, if you don't mind.
Yeah.
It's something I think relevant to last session. So
Okay.
basically, I just about microservices. So let's say our project has a microservices and hosting them. And do you intend to cover those as well in this session? Like,
Uh, Today I am not planning to, but I have a containerized application as part of this workshop. Uh, like you mean like how to deploy something like
yeah, exactly.
Dockerized application. Yeah,
Yeah,
I will,
how
I will,
those come together.
I will have another workshop. Like we have two more workshops, so I will try to demonstrate one application, one workshop on that. Like we will be using services like ECS, ECR, and then EC2s also. And then we'll have a Docker application, and then let that scale as needed. We'll do that in a coming session. For today's session, we will be just using the server level scaling, not the microservice level scaling. Yeah, yeah, that's a good
Okay, thank
question.
you.
Yeah, because that's how the production level systems currently operate. And there are still some systems that go on the EC2 level, but most of the advanced production level things they operate on the on microservices, so they are scaling and scaling down on the service level rather than the instance level. So let's do that. I think I should first do the I want to add my score that credits thing here. No, I cannot do that now. I have to log in as a root user. Let's do that first so I can show you how to contact you. I think this is where we should be about. So I go here, redeem credits. So, so I'm going to navigate this to the other screen and enter that promotion code I shared with you today. Yeah. So, so I have $25 added to my account now. I'm going to sign in as an ID from the second. Okay, now we will go to EC2 console, and then now before we let's see. Okay, we'll go to the load balancer console directly and then create a load balancer. So we want to go to this application load balancer, and then we do some like application load balancer. It has to be internet facing, IPv4 addresses. Then we have to select our project VPC. Then we want this to be in so I have to select the public subnet here. On the private one because load balancers have to be placed in public subnet. Then if you go to the this best practice view, so we have to allow the internet to reach on port 80 for this load balancer. So what we will do, we will don't have a screen group here, so I will go and create a new security group first for the load balancer. Just HTTP 880. Yeah, prepare description. Yeah. So outbound all traffic all traffic to the internet should be open. In security group, now we have a security group for this load balancer. We can connect it here. Refresh, we should see the BLB security group. I remove the default one. Okay. Then now as I told you, this load balancer will be directing traffic to a target group. That is a set of web servers. So we have to create the target group now. So I click here. And then, so target type now. The beauty of this thing is you can, if you want, you can direct traffic from this load balancer to another load balancer if you want to. Or if you want to have like a serverless application, you can direct it to a Lambda function. Or if it is like serverless application like Fargate or anything, you can use IP addresses instead of instances. So today we are going to direct the uh, traffic to EC2 instances. So we select instances and we declare web target group protocol HTTP VPC is this. So we'll send so if you allow HTTP1, it allows both HTTP 1.1 and HTTP2. So I will go with that option. So health check. So health check is another important thing on the load balancer. So what it does is before directing traffic to the target group instances, it regularly checks whether the instances are healthy. So how it does that is it just access that IP address on port 80 like the without any path variable like this. Then check if it gives a HTTP 200 response. If it is a 200, that means target is healthy. If it is something else, that means target is not healthy. So load balancer will not direct traffic to a unhealthy target. And so this you can specify things like how often we want to do those health checks. When you want to consider a target as unhealthy, when you want to consider target as healthy, you can specify all these parameters here. So traffic port, so health check port should be the like traffic port. If you want a different port, you can do that. And one other thing, so health check sometimes in our applications we define a separate URL path for health check. Sometimes health check we can have something like this, but now we will be using just the root location of the application. And so this means this healthy threshold they are explained here. So healthy threshold means how many consecutive health checks are required before considering unhealthy target healthy. So if an unhealthy target receives 5 consecutive health checks and they return 200, then load balancer will think they are healthy. So you can specify, change these values if you want. After verifying 3 health checks, if you want to move the target to healthy, you can specify that here, or you can leave this as default. So I'm going to leave this as default, and the success code is 200. So any value 200 to 299, you can or you can specify if even if a 403 also you can specify as a success code, but general practice is to response codes with 200. That is what you consider as healthy targets. So I'm leaving the rest as default. Let me double check. It's good. It's good here. Now, so this asks us to register any targets for this target group. We will not do that. What we will do is we will do the auto scaling and spin up instances, and they will be registered under this target group. So if you want, you can click these and add them as targets, but we are not going to do that. So this is the target group. So now the target group is created. We should be able to continue with our load balancer creation. So we have the root target group. So this is the one listener rule that we have. If traffic is coming on port 80, you direct them to this web target group, instances in this web target group. This global accelerator you don't need, it is for production level things. It's not needed. It's good. Yeah. And the load balancer is being created. Now load balancer is ready, target groups are ready, and then we want to have our web servers. We will what we will do is we will create something called an auto scaling group. So based on the CPU usage, instances will add or get removed from the auto scaling group, and then when these new instances start, we have to have something called a template for the instances to follow. So whenever CPU usage goes high, when we spin up a new instance, we should give that a template. Okay, you need to spin up instances of T2 Micro. You need to spin up instances of Linux AM, Linux, Amazon Linux AM 2. Or you need to spin up instances in this security group. Likewise, you have to specify the template for those instances that are coming up. So what we are going to do now is create the template in this launch templates page, this console. So we go there. To create launch template. I say template. So I click on this so we can easily set up auto scaling also here. So we want to use the Amazon Linux and maybe it's I'm going to use the Linux AMI2, this one, not the latest 2023 one, because my launch template code, everything will work on this AMI. So the instance type, I want to use the G2 micro. So the new instances will be in that type. So we will let the same Bastion key pair for these instances to troubleshoot, like to SSH into. We can use that. And next, so the subnets. So these new instances have to be launched in the private subnets. So we can so it seems like we need to have two different launch templates for each subnet. So I'll just launch my instances in the private subnet. Like UST one in just one of the private subnets. Okay, and now what we need to do is, if you go to the page again, this best practice, so the web server should be able to receive traffic from the load balancer security group on port 80, and it should allow all outbound traffic. So what we will do, we will create a security group. Auto scaling group, security group. So I think it is this project will be selected, and we direct traffic from on HTTP 80 on web ALB. Yeah. So ALB. So we want to direct traffic from port 80 from your ALB security group, and we want to do some troubleshooting by SSH into the Bastion, by SSH into the web service. So for that, we should allow Bastion also Bastion security group also into this web service. So what we want is we should allow SSH. Should allow SSH and Bastion security group. So we can SSH from Bastion also to this to these instances. So those are the environment is and so the rest of the thing we can leave as default.
Keep it to that. Okay, well, that's a lot, so you get wrapped in all your pieces. So get that. Do we just?
So I just essentially submit
Oh, there's something. Oh, we could do like something tomorrow. What were you doing? You have a lesson at 7, so I think before 7, you can do it in before like 6:30. We gotta get to our other lesson. Will you?
let's do it this way. And
Well, we can. Is that weird?
so there is an issue with our security group. We'll fix that.
So we'll just come from that, so then we can, so your eye will be feeling better, and then hopefully you'll be there, but that's not bad. Okay, awesome, well, we will see you.
Let's go and see the security groups. Just create.
You don't wanna miss it either, we'll have some news to tell you when we come and see you tomorrow.
The security group clear and assign it clear.
We'll see you tomorrow. Okay, awesome. And now it's just.
Should be able to select it here. Now launch template is ready. And now we have to go and create the auto scaling group that We'll call this launch template whenever it wants to scale up. So the launch template, okay. Okay. Good here. Check location. Here we specify where we want to launch the instances. Okay. So we don't want our instances in the public, so we don't select that. Okay. So we can attach this auto scaling group to a load balancer directly. So this is attached to an existing load balancer. So we can specify directly target group from the load balancer with target group. This I'm going to leave as default. So help chain grace period means so sometimes when you spin up an instance, if it needs to run some scripts, some long scripts before it starts up, you will have to just 1 second. I made a mistake in the launch template. I didn't go and recreate one because we didn't specify the scripts we want to run. Let me create a new launch template. Okay. Stable the current one. Yeah, quickly going to create this because we some same steps I followed. Just, Last year, select system. So this advanced details. So we enable something here. Enable detailed CloudWatch monitoring. So what it does is like generally CloudWatch monitoring is the monitoring tool you have in AWS. So it records things like CPU usage, memory utilization, number of income requests, error codes and all. So if you enable detailed monitoring, it gets those metrics every 1 minute. But if you disable that, you will get those metrics every 5 minutes. So we want to have it enabled because we want to scale up fast. So we leave it enabled. And then here, this is the one that I missed. We want to specify some script to run the Tomcat server. So, I'm going to devices. Sorry, I had a public announcement going on around me, so I had to mute. So this is the script you want to have your Tomcat server running, and we'll see um, how we can scale up on this. So I'll share the script with you along with the video, a link with the video to the script. So we are in addition to the Apache server, we download this stress tool so we can artificially increase the CPU usage to see how the auto scaling works. So this is all. I think I'm not missing anything this time. It's good to know. Right now we can go and do the auto scaling. Let's set up. Specify the project previously and the private subnets. And so whatever the instances that are starting on this auto scaling group, they will automatically be connected to this target group. So the load balancer can directly send traffic to those instances. So we don't need health checklist periods. For those scripts to run, download the libraries and all, only like 80 seconds. That should be enough. Just as you can see that. So maximum we'll put like 4, so we don't increase more than 4. And so desired capacity. So desired capacity and capacity, like we will always have one instance running, and based on the CPU usage, you can increase the number of instances in this auto scaling group. So target tracking scaling policy means it tracks a particular target. If it increases a particular threshold, we will add new instances. So the metric we use is the average CPU utilization, and let's assume generally we set it to like 80 or 75. When the CPU utilization is over 80, we add new instances. So for the testing purposes, we will set it to 50, and we put here another 80 seconds, right? So before it's metrics are recorded, we leave like 80 seconds for the instance to start and warm up. Scale out things, scale. We don't need to enable any of that. Okay, notifications, we don't need any notifications. Sometimes in certain production system need the teams to be notified when the scaling or scale up or scale down happens, but we don't need that. That's optional. So everything seems good. And let's see how the instances get registered in this auto scaling group. We may encounter some issues, but I will help you troubleshoot that too. Now, if you go to auto scaling group, you go to instance management, and you see now one of the instances are being created. Okay, so it's still in the pending status. Health status is health. Instance health is healthy. Let's see. Let's go to the target groups also to see if the target health and instance health is different. Instance becomes healthy when it finishes the initial script, and when it the AWS does something called system status checks. So if those status checks pass, this instance becomes healthy. But target becomes healthy means you have to pass the target should respond to the load balancer with a response code of 200. So we'll see if the targets are registered. So it's still in the initial stage. Let us scrolling group. It says in service. So this instance is up and it is ready to get traffic. But let's see if the target group is registered in fine. So it becomes unhealthy. So we'll see why is that. So what we can do, we can actually go to the load balancer and enter it in our browser to see if we can reach traffic. Let's get this DNS name. So load balancers, they don't have a public IP, they just have a DNS name. So when we actually go to host a website, we have to just add some record in this Route 53 service to direct to connect the domain name with this DNS name. So all the requests to that domain name, let's assume it's ui.edu, and you connect it with this DNS name, so then the traffic will come to this load balancer. Trying to reach. Okay. So we're getting 502 bad gateway because we don't have any healthy instances running. So what we can do, we run the servers and see. So let's see why it's giving this bad gateway. So we go to the load balancer security group. So 18 boundary is allowed. 1 point is allowed. Okay. Now we will go to the security groups of the instances. So this file. So it's security group. So it allows okay. So it allows port 80 from the security group and product plus security group. So what we can do, we will SSH into the web server to see if the web server is running. So what we can do, we are going to get the so we have the project list right now, but it's oh, we will need what we call this we need SSH agent, because what we need to do is we need to first connect to the Bastion and then we have to go to the web server. So we have the SSH key in my local machine, but Sorry about it. So we have to because the when we connect from Bastion to the web server, since we don't have the PEM file there, we need to add it to the SSH agent so we can do this chain SSH from one instance to the other. So now I have added my PEM file to the agent, so I can now use SSH minus A. So it will get this PEM file from the agent, then connect to the this Bastion allows only the this VPN, so I will connect to that first. Okay. So let's do this. Basically, and it should work. What you can do, we will connect from the we will try to bring the project PC complete submit. Okay. It's connecting pedestrian and safe. So to use project last year that then we have to use that. But so we were using one wrong side. I correct it. So what I need to do. Okay, now we are in our bastion and now we will process it to. Are you guys in a hurry to leave? I think we are past the time. You want to stay, you can stay. But I will do the demonstration for the auto scaling and then stop the recording. If you have any questions, feel free to ask while I'm doing this. So, successful one of the instances in the scaling group. Let's drop this one. Let's get rid of all of that. Now let's see. We need to see if the server impact service have is that. It seems like there's something wrong with our launch template because the HTTPD has not started yet. What I would do, I will I'm going to run these commands to see if they are my launch template commands. I want to see if they are any. Okay, so we have an issue here, some network issue. So our application servers one didn't have the chance to go to internet to get the libraries. So what I would need to do for these private subnets, to the VPC, I need to add a route to our private subnets to go to internet. Let's do that very quickly. So yeah, this one. Yes, that is route table. So it has only a local route. So we need to add a internet route to this. So we can go to it. Yes. Route table association. Yeah. This is how we troubleshoot some network issues in the sanctuary world. So I put here for the internet route. Send the traffic to the internet gateway. Project internet service. Yeah. Just same thing I should do for the other private subnet route table. Now it should work. Let's see. Okay. Run this command and see. Something to propagate the routes. It could be the person. That lost is okay, I'll wait today. seems like we have issue with connecting to the internet. We should resolve by this route actually. I'm not sure why it's still failing. So start the workshop for today and then we'll continue from here next week. And just the demonstration and auto scaling. And one thing I wanted to tell you is you better, if you have multiple instances running like this, you better shut them down. Like for instance, and when we want to do only learning, we can start them up again. Because otherwise, if you hours and go out of the free tier, you will be charged. And so just keep that in mind. Similarly for the RDS, for databases you are not using, if you remember to shut them down because they are too expensive services in AWS. So we'll start here for today for the workshop. And if you have any questions, please feel free to ask. I will share the recording with the fix to this, and you can follow that along the week. Yeah, if you have any questions, feel free to ask, or you can stop the recording and drop.
Thank you. Yeah, good for today. The only question that I had was that about Kubernetes. If you could include that to this session as well, this, I mean, the workshop series, that would be very valuable about microservices, hosting them, and those things, or whatever the related knowledge for that.
Yeah, sure, we'll do that.
Okay,
Okay.
thank you.
Thanks.